So this is the next to last class. Uh, no more technical content or assignments. Remaining two classes are context, and the assignments are just to do with the final projects. So to make room for the system integration week, I've merged what were two separate classes, but they're very closely connected. One is a tour through what can you do with the skills we've just covered. And the second is what is a final project. So I'll do half a class on each. So we'll start with applications and implications. Sorry, Joachim is noting, I know you were trying to volunteer a wild card. Is it a food mold you wanted to share?
Yeah. Hi, Niels.
Yeah.
Before all, it's a pleasure to participate in your class. I'm very excited, nervous. So I'm sorry about my English. I'll start with my presentation.
Sorry, Joaquin, I'm sorry to interrupt. This isn't the random review time. We're in the lecture. I'm just looking to see what in the chat you posted an example of making a chocolate mold. Is that what you wanted to show?
Yeah, yes. This is a week review.
Okay. Good. Good. Your English is fine. It looks like the chocolate came out beautifully. So thanks for sharing that. Okay, so the first of the two topics today are with what we've covered, what can you do? And the assignment is now to really drill in on the final project. And I'm going to spend a while talking about that. But let's step back. So these are the skills we've covered. So what can you do? An important thing you can do, each of these is an image linking in somewhere. During the pandemic, I coordinated a working group, and this is links from that grew to a few hundred people working on the pandemic response. And many labs made PPE, personal protective equipment, to fill broken supply chains. One of the things in this working group is there was a lot of research on what makes PPE effective and in some cases what actually makes it dangerous. But there are a number of other projects that ended up coming out of this, including things like help with testing, characterizing, and modeling, and then deploying. And there are impressive projects like a lab out of Mumbai coordinated production all over India to do a large-scale response to a health crisis. There is a gap between DIY solutions that go quickly but don't scale and mass production that scales but can't go quickly. And the pandemic was an exercise in distributed production that filled in an essential role in the pandemic response. So you've been making lots of electronics. And oh, let's see, trigger warning, there's an image in the chat of a large number of Furbies. You've been making an electronics. People buy electronics. This was a guru at a fab lab in Providence who ended up starting this business to sell electronics he's developing. And so this is going from a weekly assignment into producing electronics. This was an early version of how to measure almost anything. This was in your lab, you use test equipment. This was making and again, this was many generations back on the hardware, but making a slow speed but a functioning oscilloscope to make uh, your own test equipment. Um, this was a final project, and this one was a boombox, and he did a really nice job on all the steps related to what we're just talking about reading the card, the amplification, and then making a complete boombox for consumer electronics. Um, phones. Oh, let's see. That link is down. This was here. I'll make a note to fix that. Um, this was an early version of making a very simple but functioning GSM phone as a Fab Lab project. Let's see the so this was many years ago, but a DIY cell phone, minimal but functional, and their Fairphone. Um, it, it is an ambitious, current state of the art. You could view it as a descendant of that, of actually making a phone. This was a simple project that I'm still fond of, which is to make a computer terminal. So this happens to be done by the founders of Formlabs. And what this is doing is implementing a text terminal that can communicate over the internet and drive video to build computer interfaces. From a terminal, this was a project done by a notorious hacker with interesting history to make a complete open source laptop. And so, not trying to beat laptops on packaging or cost, but the entire design is open source and extensible and hackable. Then if you make a cell phone, you need to pay somebody to connect your cell phone. This project started in Afghanistan, and then a version was deployed in Kenya. This is making city scale networks. And so this was done at a fab lab in Afghanistan where there just wasn't communication infrastructure. There weren't telcos coming in. And it experimented with a number of high gain antennas and radios. And what ended up winning was just making a parabolic reflector. So what you're looking at, so sadly, Arecibo, the radio telescope failed, but this is a receiver at the bottom, at the focus of a giant parabolic dish to talk into deep space. This is a more modest version with the ShopBot make a large parabolic reflector and then put an antenna and radio at its focus. And that can do about a 10-kilometer link. Uh, let's see, there's a link in the chat about CyberDex. So this can make about 10 kilometer links. And what ended up going at the focus after a lot of experimentation was just using the Open WRT project, which takes access points and builds open source Linux kernels on them. And then there's some tweaking you need to do about back off for the long round trip time. But with that, they made a citywide internet. And then in turn, they use that to cache local content like Wikipedia and the Fab Lab archives and things like that. And then it's just implementing Wi-Fi over long range, and so you can make short-range Wi-Fi terminals that connect to this to build your own regional internet. At some point, I'd love to do a project to do that at a country scale, but city scale networking is very accessible. Um, there's in the chat, there's a note about the very lively cyberdeck community. Um, lots of hacking for cyberdecks. So that's an example of building your own networks. And then CubeSats are a standard form factor for making a small satellite. And this is an organization for CubeSats. And what goes into a CubeSat is extremely close to what we've covered. You need to do a, a better job than average on mounting just for the launch vibration. And what makes CubeSats possible is when there's a bigger payload, often there's some space and some mass available around the big payload where the CubeSats can fit in. And so there's a number of programs to provide access to CubeSat launches for things like educational programs. And if you descend into that, you'll find it's surprisingly close to everything we've covered is already what you need to make a small satellite. So machines we've seen at length, and we had the recitation. And uh, one of the transitions is come to the Fab Lab not to get access to the machines, but to be able to make the machines. Um, uh, so yeah, Babkin is asking about uh, radiation. So that's one of the surprises. The historically rad hardened electronics is very derated, very different regime. But there was a famous phone sat project from NASA Ames where they just took a cell phone and launched it to see how well it would hold up. And one of the surprises is with the distributed error correction through the electronics, how well it worked. I wouldn't rely on it for long duration safety critical space travel, but very close to that was Planet Lab, not directly, but roughly spun off from that. And Planet Lab made remote imaging satellites using technology, essentially consumer electronics technology, not traditional space qualified technology, and has been very successful with that. Yeah, these are the founders doing it in again sort of Fab Lab type space, not space qualified clean room. So yeah, I've talked a lot about machine building, and in fact, let's see. I don't know if I can find it back in the chat. Carola posted a nice page on their mini Zund. Let's see if you can repost that, Carola. Um, their machine is a great example of a mini makerspace machine. Good, thank you. So the mini Zund is a great example of sort of a complete mini makerspace machine that you can make in the lab. And having made it, skills and jobs are local. They don't have to be the same. You can customize them. And in particular, the machine itself is a teachable moment. So if you deploy in a local school one of these, you can learn to use the machine, and then you can learn about the construction of the machine, and you can learn to modify the machine. I've mentioned multiple times Materiome. We saw a fun example today in the conducting dough. Materiome is a great resource and has been maturing for given natural sustainable feedstocks, the range of types of materials and for a range of type of purposes you can produce locally. robots. Yeah, we saw Edwin's lovely robots. This was a project of students in my lab for a robotics class. And let's see, I don't know if the videos are linked, but this was to make a leaping robot that has really interesting dynamics. And reason I'm showing it in particular is basically this was all a ShopBot project. This was just beautiful machining on the ShopBot to make this leaping, bounding robot. I've mentioned inflatable for soft robots. Saul Griffith and colleagues at other labs have used large format cutting and sewing to then make, this is a pneumatic exoskeleton, this is a robotic arm, this is a creature you can ride on, this is a car you can drive in, as large scale inflatable robotics. With Jim, we saw boats. This was the example of Sam's gorgeous kayak. Beautiful machining to make a boat. Yeah. Wilbur, I'm going to mute all. Okay, I muted Wilbur Giron. Bicycles. In Wildcard Week, I mentioned composites. So in this case, Kenny didn't try to make the rest of the bicycle, but the core bicycle frame was done by laser cutting cardboard, making this interesting form, and then using the cardboard as the form for the composite layup, and then just keeping it in it to make a composite bicycle frame. There have been a number of projects making skis. John was responsible for the puppets, the puppet I showed at the very first class, and he got very interested in ski production. He ended up wanting to make motorized skis for his final project, but went through all of this work for composite laminated layup to make these beautiful skis. Many drone projects over the years, but Danielle Ingracia, who's behind the in machines and the open Fab Lab kit, made a series of drones where he made all the parts of the drone, and in particular, he made the control system, and so made this lovely family of drones completely out of the lab. Cars may sound crazy, but this was an ambitious project in the Barcelona Fab Lab to do a Fab Lab car. And in the world of electric vehicles, it's gotten much easier than in the internal combustion era. So this was a version of making a whole car as a Fab Lab project. For environmental monitoring, this started with Tomas Diaz in Barcelona. Ooh, they're having a site issue. To do environmental sensing, and that turned into this smart citizen platform to do community sourcing of distributed environmental data. And this has had an important impact in Barcelona in the urban planning, in gathering data, feeding into the city scale planning. Energy, they're examples. These aren't mature enough, but this was an example of Tom, who colloquially was called ShopBot Tom for how he bonded with the ShopBot. And this is his composite layup for Maker Faire Africa of making a wind turbine. And I'd love to see more work like this, that once you master composites, And then the power electronics, you can do wind turbines. Uh, for food, this was, I showed this early on of aquaponics uh, done at the Agro Lab, sorry, not the Agro Lab, the Green Lab in Barcelona in Valdora, of making an aquaponics system. And that grew into an Aqua Pioneers project. And you've seen multiple times Luke and colleagues at AgroLab um, uh, uh, building technology for agriculture and building hydroponic and aeroponic systems. Uh, so in biology, there's a lot of manual pipetting. This is a commercial biosystem. And then this was an example of taking the rapid machine building, but using it to build a biorobot. And that leads into one of the classes spun off from Fab Academy is Bio Academy, where you learn biotechnology. And an early goal that we're getting closer and closer to is not just learning molecular biology, but using the Fab Lab to produce the biolab. Most of the tools in the biolab you can produce with the Fab Lab tools. Microscopy. This is a former student, Manu. He developed the Foldoscope, which is a $1 microscope. And Open Flexure is a project developing open designs for microscopes. And Manu has a project, Squid, which is developing a whole architecture for assembling advanced open microscopes. So that's building your own microscopes. And then this is a link to the meeting I mentioned. And we're going to reprise this next year, building not simply DIY, but advanced scientific instruments. This is the person behind the quantum definition of the kilogram, which is a really interesting story. This is the person behind the microscopy. This is one of the leads for image processing. This is Raman spectroscopy for chemistry. This is rheometry for material properties. These are some of the collaborators from the National Institute of Standards. Yeah, this is Manu on the microscopy. I had mentioned this is the spectrometer. Sorry, this one is the spectrometer. He's making do-it-yourself atomic force microscopes. Atomic force microscopes are like a record needle, but what you're measuring are the bumps are individual atoms. And so he's doing versions of DIY atomic force microscopy. And so these are examples of not making rudimentary measurements, but making really advanced scientific instruments in a fab lab. We saw an example today of producing prosthetics. This is a project that's 3D printing prosthetics. Again, a lot of this is 3D printed. Commercially and medically, there's much more use of composites, and I'd love to see more Fab Lab production of composite prosthetics. But this is a classic Fab Lab projects where you really need to customize each one for each person. This was a fun just molding and casting project of a student who wanted to look at making footwear. And so what he's doing is he's machining a mold. In the mold, he's casting a elastic, softer material. And then in the post through it, he's casting a harder material for the vertical support, and then using that as the basis to make a fairly advanced sneaker. Um, This is a niterate. There's been some complexity in the history of this, of open, proprietary, and open, but this is a version developing an accessible knitting machine as one classic commercial supply chain thing that you could move for local production. Um, and one of the software leads in that had worked in my lab and is right now working on a startup aiming, an early version of the startup was sort of doing all of this as a Foundry service, as a cloud service. Uh, Toys. This was a project from the VOG. Um, Hank, do you know anything about what happened to him?
Yeah, I met him recently. So he's now working at a Canadian company making playgrounds for children.
Okay.
It's
Um,
really, really beautiful.
yeah. So um, this may be one of the. So these were toys, and in particular, this may be one of the most beautifully finished projects in a fab lab. He's just using the same tools you're using, but just really worrying about speeds, feeds, processes, workflows, just making these beautiful toys. And again, just using the tools you're using, but just really doing a beautiful job with them. Simple, classic, but one of the most beautiful things to come out of a fab lab. Um, for art, what I'm linking to is I've mentioned this a few times, but just to recap, Haystack in the US is one of the leading craft retreats. This is where glass blowers and printmakers and many different crafts retreat. And we run a fab lab there. And what's interesting is the fab lab there, largely computers aren't used as design devices. Rather, the computers are used as media translation devices. So lower left, an artist was struck by how the light would sparkle on the main ocean. And so we took an image of the ocean, turn that into topography, and then use that to slump glass to make glass that sparkled like the ocean. What I'm showing on the right is one of the printing processes is intaglio, where you squish the paper into the printing plates. And it was very laborious to make the intaglio printing plates. And we realized the PCB production process is exactly doing what's needed for intaglio printing. And so these are these beautiful, just sort of PCB boards turned into intaglio prints. So just an example of art collaborations. Uh, Going back to the VOG, Alex, one of the early gurus at the VOG, um, got excited about musical instruments. He made this beautiful tongue drum. Okay, there's Alex playing it. And then he did spend quite a while making this gorgeous bass guitar. Um, so here's Alex playing the bass guitar. And there've been a whole series of guitars in Iceland, but this beautiful bass, again, as a Fab Lab project. So that's musical instruments. From there, you can make furniture. Let's see, Ohad, are you on today? I believe Ohad was on earlier. This is one of the best furniture making projects. In Holon, a mixed community in Israel, there was a kind of a sad community space. And so with the kids, they designed and produced all of the furniture. And so the furniture did what the kids want. And it had this huge effect in the community of all the kids wanted to grow up and become designers inspired by that experience. And so, a great task is Fab Labs making Fab Labs, including starting with an empty space and populating the furniture in it. So that was Ohad's makeover. Then there have been many house projects. I'd say the biggest house project ever was the Fab Lab house that almost destroyed the Barcelona lab. And they had to pull in a lot of help with it, but designing and making a solar house, including all the furniture of it, as probably the biggest rapid prototyping project to ever come out of the Fab Lab network. Then let's see, let me update that link to Danielle, who started as a Fab Academy student turned instructor, has now been driving the Open Lab starter kit, which is a curated version of each of the machines in a Fab Lab, producible with open designs. And really maturing from the machine works to the machine is competitive against commercial machines to we like it better than commercial machines. Let's see, this is a link to Blair, who's one of the gurus of a Detroit Fab Lab, has been working on building whole communities now. He's doing really interesting work in northern Michigan, not just building a lab, but that's migrating to designing and building a community. And I'll update the Blair link for where he's doing that. The Fab Lab project then spun off the Fab City project. This is a design study on making a sustainable district in Barcelona anchored around the Fab Lab. And the Fab City initiative has now become a foundation of cities around the world signing up to this countdown to produce what they consume. And I've gotten re-involved in this recently to work on the technology base, on the enabling technology of just in this last half hour, I've shown examples of food, energy, shelter, but looking at how much of that can you produce in a city? How does it compare to how it's produced? How does it scale? To really look at displacing what cities consume. And we're working with a number of fab labs, including Bhutan, Hamburg, Boston, on the measurement part, on just figuring out what goes into a city, what goes out, and how do you measure your progress against this countdown. And this is a link. Let's see, I'm showing Frosty's lab in Vestmannair. And this is a link to an article I wrote with my brothers on starting to look at the economics of what does it mean to sustainably produce locally and how does that change an economy. And there's been interesting work on measuring it. So is traditional money even the right unit? There's been experiments on fab coins, ways to have blockchains that measure contributions into the network and then benefits from it. Starting to think about if anybody can make anything anywhere, how does the economy function rather than the way we currently segregate living, education, work, and play. So all of that's just a somewhat anecdotal tour through the range of things you can do with the skills we've covered. And so now the second half is going to talk about final projects. And let me go over the assignment after the final project tour. So I'm going to tour final projects, and then I'll end with what is the final project, and I'll end by talking about project management for the final project. But I want to first inspire you with examples. So this one was one of the most evocative ones. And some of these I've shown during class, but I'll reprise. So this is the most delicate final project. There it is. It just flew by. It's making this gorgeous flapping, flying creature. There. It's just beautiful. And then here it is flying outside. So that was an amazing example of system integration to make something lighter than air that can fly by flapping. I showed this one. I remember this came up, but I'm going to reprise to show it. This one is a great one in just production values and finishing it. So it's making a robotic skateboard system. So with this nice motion control. I'm going to jump ahead a bit. So this is the production video showing the steps. And here it goes. And yeah, I just love this one because there's no visible technology. It's just magic. It just works. Um, so that, it's one of the nicest finished projects.
Oshaku is Japanese traditional etiquette for drinking. To pour sake for the people around you. If you do so out of kindness, it's very nice. But sometimes it becomes like an obligation. Why don't we stop bounding by old customs and solve the problem by digital fabrication?
So aside from being a lovely project, I like this one. You're each going to make a video that I'll talk about to document your project. And the video doesn't need to be boring, that you can tell a story with the video presenting your project.
Tired of your achievements not getting any recognition by your boss or fellow co-workers? Or tired of your cost-cutting and efficiency drives not being appreciated by your staff? Then this is for you. Acme Industries brings you a new innovation in self-loving, the pat yourself on the back mat.
So let's see. I think that
Our team of master practice new mechanic. Our phone lines are now via settings. And
I think that was Machine Building Week rather than Final Project Week, but I love that. And again, that was a great example of fun storytelling. Let's see. Nadia, I showed in the Design Week. Gorgeous project showing integration with this puzzle. I won't go through everyone, but each of the projects is here because each one shows something. Yeah, this one was he loved car design and loved cars. And so what's shocking is all of the cars you're going to see were made in the lab. So the technological part was the data from the cars, But this was a massive effort just on finish. So designing the cars, and then starting with 3D printing, laser cutting, milling, but then a lot of work on beautiful just finishing. Yeah, so just this part, just sanding, painting, right there, turning it from a average 3D print into these beautiful cars. Let's see.
Are you a parent who's sick of pushing a scroll? So why are you
so he was terrified in the class. He had no technical background and was terrified by everything, and ended up developing this robotic stroller and using his baby as a test subject.
How free my hands are. I can do anything. Answer
the let's see, this is one of my favorite projects for the integration of every week. So it's a miniature smart house, and each part of the house is demonstrating. Let's see. Let's get up to showing it. So system integration of all the parts, and then it ends up with the. I think she shows it. You can control the elevator. You can fill the swimming pool. You can open the garage door. You can vary the lights. There's a doorbell where you can see who's coming. So every week is part of the smart house. There's filling the swimming pool. So that was the whole class in a smart house. Then many of you have gotten to know Adrian. His day job is with full-size trains. And so his project back when he was a student was this train model with the lights and the crossing and the Fab Lab train. And again, he's done a really beautiful job of finishing it so it doesn't look like technology anymore, but just the train model. So everything is nicely packaged. And now comes the composites to make the landscape. And then making the landscape. And then finished, it's this beautiful train system. Projects are on different scales. So this one was a crazy fast Rubik's Cube solver. There, it just did it. Then on a much bigger scale, this was from Vegan Ashram making a solar powered shredder. As a much bigger scale project. Let's see, this project from ULB was one of the most interesting ones, in part because it's so disturbing. It's from somebody who works in the theater, and this is as part of this theatrical production, has this fountain of despair. So it's alarming but beautiful. And then again, my favorite projects are ones where it's just magic, where there's no explicit manifest technology. You just see this gorgeous and disturbing fountain of despair. Question in the chat if you can't get the electronics working by the deadline. I'm going to spend about 15 minutes on those sort of questions. The answer is you need to simplify the electronics. Let's see. Lux, I like because this was an unusual project that it made an interactive lamp, but along with the lamp, did the packaging to distribute and assemble the lamp. So worried not just about finishing the project, but here, what she's doing now is she produced the packaging to distribute her project, which was system integration, not just in the finish, but in the distribution of it, which was a very impressive step. Nuria or Adrian, do you know what's happened to her?
Yeah, she's a teacher in the university and the manager of the Fab Lab, indeed.
Great. Okay, good. Glad to hear that happened. Let's see. This one was a great example of telling a story. Let's see. Is this the final video? Okay. This is a nice example of telling a story in a final project. Oh, is there audio? So he's solving the problem of your cereal gets soggy when it sits in the milk. So really nice integration that he's doing in real time while we watch. So he just assembled his project as part of the video, and then it dispenses the milk just in time as you're about to eat your cereal. See, this one from Barcelona is one of the most beautiful and magical projects. It's a levitated weather display, and so the cloud is levitating, and he's coupling into it and using it to show weather data. And so that it's one of the most magical projects. Let's see, for Cloud.io, this is one of the biggest projects ever. This was a human-size hamster wheel. So this was make something really big. That's heroic. On the other hand, this the Sensitive Dog project I like because it's a beautiful, complete
Sensitive
project.
Dog is an interactive sculpt. Like a real dog, Ocean is a source of imitate that projects we interconnect and embeds. both part and rig contains a capacitor to the motor, just like a real dog.
So it's not heroically difficult, but just beautifully integrated to make this interactive dog. This I showed in System Integration Week. This was one of the best integrated projects of the scoreboard. Since we talked about guitars, Vili made this beautiful theremin, so a sensing slide guitar. So a nice example of the musical instruments. Let's see, there've been a few music projects. I like this one because the Moog synthesizer was the classic modular synthesizer at the beginning of electronic music. This is doing something like that, but each module is digital and doing one function, but exchanging digital data to make a modular synthesizer. This one I like because this is probably the smallest final project. This was Smart Dice, and lots of development work. We get to the end, and the whole final project is about 1 inch big. The whole final project fits in this tiny cube to make Smart Dice. This is one of the nicest end-to-end projects. This one is a robotic chess set where he did molding and casting to produce the pieces. He then did a motion system to robotically move the pieces. And then he did a communication system to link between multiple sites. So you can play a remote chess game and you can see the pieces move from the remote game. So moving there. And at the very beginning in the first class,
Hi, I'm Kelly, and this is my screen lock.
I played this, and
do you ever find yourself in a situation where you really have to any?
So we had gone through this. She saves up the screen and plays it back. But now she goes on to show it was a molding and casting project, and then embedding all the electronics to save and play back the screen was ages ago, and one of the first and still one of the most nicest final projects. So that's a tour through notable final projects. And so now we're up to yours. So what you're going to make is a masterpiece. Now, the word masterpiece has come to mean like a great work of art, but it actually has a very precise meaning, which is traditionally in a guild, to graduate and join it and show mastery, you produced a masterpiece. And the point was not that it's a legendary work of art. The point is that it shows your mastery of the skills. It's a piece to display your skills. So the goal of the project is to show we've done everything separately to show you can do it together. So we want to see 2D and 3D design. Could be laser cutting, vinyl cutting, 3D printing, milling. We want to see a role for both adding material and subtracting material to know when to use each. You need to design and produce electronics. Embedded microcontroller means you don't make a daughter board for an existing processor board. You make electronics the processor goes into, but other than that, anything is fine. AVRs, SHAOs, PICOs. As we did last week, you need to design the system, how it's integrated and packaged. As much as possible, we want you to make what you can rather than buy it. You can collaborate, but if you collaborate, you need to be able to separately show subsystems. You need to show a whole working thing. So somebody could make a motion system and somebody else could make an end effector that we can see separately. And then I want you to answer questions. So at this stage, I want you to specify what's your project going to do. Well, actually, let me jump to these questions lead into when you present it, you're going to answer them. So what does your project do? What's come before you? So it doesn't have to be the first one ever. It doesn't have to be unique, but I want you to do some homework and learn from others. There's a notion of standing on the shoulders of giants versus standing on the toes of giants. Learn from what's come before you. What did you design? What are the materials and components? At the beginning of the class, everything just came from the lab inventory. Now I want to know where did what went into your project? Where did it come from? Rather than just lab inventory, what did everything cost? What did you make? What processes? What questions did you answer? So like in Barcelona, what are the different options to drive the speakers? For that scanner project, what are the different approaches to scanning a hand? I want to know what did work, but I also want to know what didn't work. Log your failures as well as successes to learn from them. Then maybe the most important question I want you to answer is, how should your project be evaluated? So not just here's what I did, but how do we tell if your project succeeded? So tell us how you think the project should be evaluated. And then what are the implications? Having done this, is it over, or what does it imply for the future? So I want you to ask and answer each of these questions. Then in next week's class, where I'm going to talk about invention, I'll go over this part. And this is often a source of last minute glitches. You're going to make a slide and you're going to make a video. And so let's go to a prior year, 2023, final presentations. So here's her slide and here's her video. The video demonstrates the project and the making of the project. And we want a 1080p slide, just a standard size. The slide describes you, yourself, your project, and you call it presentation.png. You put it in the root of your directory. And then the video clip is encoded to HTML5, 1080p. It's about a minute long, which means it's about 10 megabytes compressed. You put it in the root of your directory. You're going to need to do that to present. And a frequent glitch is at the last minute, the slide isn't visible. And so the final presentation schedule is already posted here. And right now, all of your slides and videos are missing. What I recommend you do is make these now as placeholders. It could be an empty slide. It could be a 1 second empty video, but make placeholder slides and videos to make sure they're linked and appear in the final site. And then over the next 2 weeks, you'll fill that in. And so to finish your project, everybody is going to run out of time. So first of all, Murphy's Law, if you've heard of it, is widely misunderstood. So Murphy's Law, the typical form of Murphy's Law is everything that can go wrong will go wrong. So let's go back. Let's see not that. So Murphy's Law, everything that can go wrong will go wrong. That's often used to say, well, I worked on my final project, but it was broken when I presented it, Murphy's Law. Murphy was an aerospace engineer working at a test range. And the point of Murphy's Law is everything that can go wrong will go wrong. Therefore, you need to anticipate how it will go wrong. So Murphy's Law doesn't excuse failure. It means you need to anticipate failure. So picking up from last week, think about all the things that can fail in your project and what do you need to do to prevent that failure. Of a connector ripping out means you need to strain relieve. Of a power supply you could fry means a protection diode. So think about that. 80/20 is the name of a construction system. And it's based on the idea that there are many ways to say it, but 20% of the work takes 80% of the time. That when you build a house, the house goes up quickly, but just finishing the house, the last little bits take most of the time. Uh, um, uh, in the chat, there's a meme version. I would say it's more like 95/5, that you'll find 95% of your project zips through really quickly. And then there's the last, what looks like 5% unpacks, and that's what can kill you. The last few details that seem inconsequential, more often than not, are what you end up tripping over. So not the bulk of the project, just the last little bits to pull it together. And that's really what the final project is about, is the integration to go through that. But you need to be prepared for little details at the end to take most of your time. There was a question in the chat about what do you do when the electronics doesn't work? So triage, I've mentioned before, but I'll mention again, if there's a plane crash and the first responders come, they have to decide, is somebody so seriously injured they won't survive that you have to make the hard decision to ignore them. If somebody's up and bleeding but walking away, they're not urgent. Triage is you need to figure out what can be saved but needs intervention to be saved. And so the question in the chat was, what do you do if your electronics doesn't work? And my answer was simplify the electronics. That you may not be able to make all of the functions that you think you want, but you need to cut back to just enough functionality to show that it works. I'm not looking for something heroic. I'm looking for, you can design and make a circuit board with a processor that does something, but reading a button and lighting an LED is not ambitious, but it shows you can do that. I've said this over and over, but you're not going to have time to document the final project at the last minute. You have to build your documentation as you go. Now you really, really need demand versus supply side time. If you do task, the final presentation was here and you're not done, the only way to do it is, we're here now, here's your presentation, and you have to divide up what you need to do each day to get there. And you need to do triage if you can't finish in a day to cut back to what you need to do. To finish, in working in spirals, each spiral ends up with something testable. So we had the hand 3D scanner. The first version doesn't scan at all, but just takes picture. A second version does take pictures for photogrammetry. A future spiral can add a laser for real-time scanning. But the key thing is you don't want to wait to test a project at the end of the development cycle. You want to keep testing and adding features as you progress. Think about modularity. If you make all your hardware as one monolithic unit, all your software as one monolithic unit, you can run out of time, it can fail. Try to decompose into modular systems you can debug and test separately. If you go back to Gantt charts, don't do task, 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 because any one task failing can block all the other tasks. Think in terms of working in parallel to keep all of your tasks moving. And then in the last week, I stressed, excuse me, system integration and finish quality. And in the final project tour I just did, I showed you lots of examples of using the same tools you have in the lab, just how beautiful it can be. Interesting. Philemon is noting just making documentation in code and then pulling it out as a version of documenting during development, of accumulating the documentation where you're working and taking, pulling it out from that. So every one of these lessons sounds obvious, and every one of these lessons has been the subject of billions of dollars of failure of major projects. Let's see, Ricardo is linking to critical path method on for scheduling prioritization. It's important to focus on what the project needs, not what you need. That may be different. You can get obsessed with something that's just not critical to the project. So for this week, set up your final project site with prepare to answer these questions. Work on your final project, really thinking about project management. You can really learn these skills and get better at project management. Next week's assignment is to post your slide and video, but I would get going on that already this week because you need to have templates in place. And then from there, next week's class, I'm going to talk about the whole life cycle of managing an invention, and then we're up to the final presentations. So use all the resources you have. You have the Adrian and team for the Saturday open time, this great group of Adrian, Pablo, Rico, all of them. Use the issue trackers. If you're stubbing your toe on something, post issues to the class and get help from that. You have regional reviews you can get help with. Now's the time to really embrace all these lessons about project management. And remember, the final project isn't your life's work. It's a masterpiece to demonstrate your ability to integrate skills. And what we're looking for is your ability to integrate. So it doesn't have to be heroic. We don't want how to almost make something incredible. We want you to how to make something. And so it's more important to finish something than here to fail to finish something more ambitious. The ambition can come later. So that's a tour through what you can do with these skills and a tour through some greatest hits from final projects. I'll see you Monday for the recitation on startups, looking at if you want to commercialize your work. And after that, we have one class, and then we're down to the final projects. So good luck, and I'll see you. Many of you will gather on Saturday, and then I'll see you on Monday for the recitation. Bye-bye.
Hey.
Bye.
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 Ciao, ciao.
Nos
Bye.
vemos.
Chao, chao.